Hello, and in this video we will be looking at A-level physics, specifically for EDEXCEL. We'll take a look at critical angle and total internal reflection in this video. So specification point 72 states that we need to be able to calculate the critical angle using sin c equals 1 over n. And we also need to look at specification point 73, which states that we need to be able to predict whether total internal reflection will occur at an interface. So as we can see in the following diagram, θ1 shows the incident ray travelling through the semicircular glass block, where it would eventually reach the interface, which is considered as the boundary between two portions of matter, which in this case is glass and air. Now, due to different refractive indexes of both glass and air, the ray of light will change direction, which would be away from the normal line, which is perpendicular to the horizontal boundary line. This is due to glass having a higher refractive index than air. So, as θ1 is increased, the angle of refraction would also increase. The highest angle of refraction possible would be 90 degrees. At this point, the specific angle of incidence is referred to as the critical angle. Increasing the angle of incidence beyond the critical angle would mean that no refraction takes place. Instead, the light ray would completely reflect, and this is known as total internal reflection. Now, using Snell's law, we can actually derive the formula for the critical angle. So we have n1 multiplied by sine theta c, which is equal to n2 multiplied by sine theta 2. And then we have n1 times sine theta c, which is equal to n2 times sine of 90. So the sine of 90 would be the angle of refraction, and as we all know, sine of 90 is given as 1. So basically you would end up with n1 times sine theta c, which is equal to n2, and then you would divide both sides of the equation by n1. So you would end up with sine theta c is equal to n2 over n1. Now this formula works for any n1 which is greater than n2. So this fraction, sine theta c equals n2 over n1, will always be less than 1. However, if n2 was greater than n1, then the ray of light would bend towards our normal line, so it would only make sense for the case where the light is travelling from a medium of greater index of refraction to a medium where the index of refraction would be less. And for total internal reflection, n1 has to be greater than n2, and the angle of incidence has to be greater than the critical angle in order for all the light to reflect. Thank you all for watching. I hope this video has made sense and cleared any questions anyone's had about critical angle and total internal reflection. Thank you and goodbye.